Hey guys, this is Mr. Urrego, and today we're going to talk about functions. The first thing we need to talk about is the relations. Okay, when do we get a relation? Well, a relationship exists when I have two quantities related to each other. All right. Right now I'm giving you a set of points: 2, 3, 3, 4, 5, 6. Right? Points or order pairs. I can rewrite these order pairs and this type of diagram. So I can say that I have a 2 here, a 3, a 5. This should be a 5. There you go. And then I have the 3 and the 4 and the 6 on the other side. If you notice, I am separating the x's and the y's. Okay, the first value of an order pair are the x's, the 2, the 3, and the 5. The 2, the 3, and the 5. The second value are the y's. 3, 4, 6. 3, 4, 6. And this is a relationship. 2 and 3, they go together. 3 and 4, they go together. 5 and 6, they go together. My x values are called the inputs. Okay, I'm going to give you kind of all the names. The y values are called the outputs. Because when I write an equation, which we're going to do in a minute, we input a value and we take out something, and that's going to be my output, okay, which is the y value. I can also write that as a table of values, x and y, the 2 and the 3. So relationship between the 2 and the 3, the 3 and the 4, an ordered pair, okay. Last but not least, the 5 and the 6. So these are different ways how to write relations and also functions. We'll talk about functions in a minute. So all these are relationships between two quantities. Okay, let me give you more examples. Let's pretend that I have, I'm going to give you, let's go black right now. So I'm going to give you a different type of relations, right? So it's going to be an input, and this is going to be my output, okay? Input, output. Let's say that I have 1, 2, 3, and it's with 5. The 1 has a relationship with the 5, the 3 with the 5, the 2 with the 5, and 3 with the 5. This is a relation. Okay, let me give you another example of that. So let's say that I have the other way. Let's say that I have the 5 here as my input, and I have the 1, 2, 3 as my output, right? Input, output. So I'm having a relationship between two quantities of 5 with the 1, 5 with the 2, and 5 with the 3. Okay, so all these are relations. So when does a relation turn into a function? Which that's a different type. That's a special type of relationship. So a function is a special type of relation. All functions are relations, but not all relations are functions. And this is what I'm saying. Let's pretend all these are relations, but not necessarily all of these are functions. How do we know when a relation becomes a function? A relation becomes a function only when for every input, there's only one output. For every input, there's only one output. Let me explain that. Right now, you see that the 1 has a 5. So let me write that as an ordered pair. 1 has a 5. The 2 has a 5. Okay, the 2 has a 5. The 3 also has a 5. Okay, the 1 only has a 5. The 2 has only the 5. The 3 has only the 5. It doesn't matter the repeating, but each input has only one output. Let's go over here. The 5 has the 1. The 5 has also the 2. The 5 has also the 3. So this relationship here is not a function. Because you see that the 5, which is my input, has 3, 1, 2, 3 outputs, right? Therefore, this is not a function. In the other way, the 1 has only one value, the 2 has only one value, the 3 has only one value. It's the same, does not matter. But they only have one value. Remember, for every input, there's only one output, okay? So that's the difference between all of them are relations, not necessarily all of them are functions. All right. Let's introduce the concept of domain and range. So when we talk about domain, we talk about the values of the input, right? Or the X values. So if I'm going to say, oh, what is the domain of this relation? Then I'm going to go for the X's. My domain is 2, 3, and 5. All the values of the X. My range. What do you think? If my domain is the X's, then my range are going to be the Y's. 3, 4, and 6. That's basically it. That's all what it is about domain and range. Okay? If I have a graph, what's going to happen? My domain, anything related to the x-axis. My range, anything related to the y-axis. Alright? Having said that, let's get into some graphs. Let's erase all this and let's get graphs. So let's say that I have this graph. Okay? It's in between this and this. Right? No arrows. So my graph starts here and ends here. If I want to do my domain, right? My domain will always only be anything related to the x-axis. And I just put my same notation. I'm going to write this in interval notation. So here we go. X-axis. My graph starts at -2. Starts at -2. And I'm looking at the x-axis. And it goes all the way to 2. Okay? Because my graph is included, you see that the solid dot, then my interval notation will have a bracket. Here, solid point, my interval notation will have a bracket. Okay? I will link a video about interval notation underneath. So inequalities and all that stuff, so you can review that. But I'm going to review anyway. Now, let's go with the range. Let's go with my range. So let me write the range. Let's get with that. Right. Okay, I'm doing range. Now, instead of the x-axis, I'm going to look at the y-axis. All right. Let's say this is the value, right? -1. So on the y-axis, I need to start from the lowest value all the way to the highest value. Same thing with the x-axis. From the lowest value all the way to the highest. Right? So anything from the left and then my value from the right. On the y, anything from below to the highest value. So above, right? Let's say that. So my range starts right here at -1. And it goes all the way to, let me see, on the y-axis, here we go. My graph goes all the way to 1. So my graph on the y-axis is covering anything from -1 to +1. Because those points are solid, then we're going to use brackets. And that's my domain and range. Let's do another one. So we have this graph. This is a parabola, okay? It doesn't matter, we don't need the function, we don't need anything. We're just looking for the domain, and we're looking for the range. So when I'm looking for my domain, I'm looking for my range. Again, the x-axis. So the x is horizontal. So basically what I do is I look my graph to the left and I look my graph to the right and I see what's going on. And this is for my domain. On my left side, I see that I have an arrow going up, but it's also going to the left, right? Because it's an arrow, I don't know where it stops. So the lowest value that I can have to the left is -infinity. It's going to go all the way to the left, to the left, to the left, to -infinity. Infinity always has a parenthesis. Okay? Same thing goes with the right. I'm going to the right because my graph has an arrow. I don't know where it will stop. So it goes up, but it's also going to the right because it's going slanted. arrow. That means my graph is going to keep going forever, which means it's going to go all the way to positive infinity. And every time you write infinity, you're going to have a parenthesis. Let's look at the range. Now, instead of looking left and right, I look up and down. Okay? So my range, up and down. I always start with the lowest value. The lowest value on the y-axis is right here, where my graph, that's the lowest value of my graph. And that value is -2. Because my line is going through that value, is going to have a bracket, comma. Then I look up. What's my highest value? Oh, I have an arrow. That means my graph keeps going and going forever. Therefore, my highest value is positive infinity because I don't know where will it stop. Okay, let's do one more. Now we have this one. So let's define our domain and range. Now, my graph on the x-axis, right? Left and right. I start with the lowest value, which is on the left side. My lowest value on the x-axis is going to be -1. That's my domain, x-axis, comma. On the y-axis, my highest value, look straight up, is going to be 3. That's the highest value. Let me do that again on the x-axis. My lowest value, I go straight down, is -1. Now, if you notice, I have an open circle on the left side. Open circle means the value is not included, therefore, I have a parenthesis. So I put a parenthesis when the value is not included. I put a bracket when I'm touching my graph or when I have a solid point like this. Bracket, touching my graph like I did in the first one on the top, or when I have a solid point like this. 3. Am I touching, do I have a solid point? Yes, so 3 is going to have a bracket. Let's go with the range. The range, the lowest value, look, on the y-axis is -4. The highest value, I'm going to go up, is 4. Again, I go from my graph all the way to the x-axis. And now, let's go back to the -4. I have a solid dot, that means it's a bracket. It's included. Then you go all the way up, 4. Open circle, not included, parenthesis. So that's how it goes. Included, bracket. Not included, parenthesis. Okay? All right. Let's do one more. So let's look at these 3. This one has, oh, I should have done, all right, let's do this with an open circle, for example. Yeah, that was in the open circle. Let's change one of them. So this one has a value of -2, and it goes an arrow all the way to the top. This one starts at -2 as well, but it goes down. This one ends at 3. Right? Sorry, ends at 3,2. Right? That's where it ends. This one has a close, open, and close. So let's talk about the domain and range of each one of them. X, domain X, starts at, on my left side, at -2. It's close, bracket. To the right, I have an arrow going to the right. This goes to the right and this goes up. So that arrow counts as going to the right and going up. It's going to the right, meaning positive infinity. My range, the y-axis, starts at -1. It's a solid dot, so bracket is included, and it has an arrow going up, meaning positive infinity. Here we go. What about here? Now this arrow is going down, so this is going to change the range. So let's look at it. Let's look at the domain first of all. My domain on the left side, it starts at -2. We said it's an open circle, so it's not included. Therefore, I got a parenthesis. To the right, I have an arrow going to the right. That arrow is going to the right, and it's also going down. Right? That's the way it counts those arrows, to the right or to the left. I'm looking at my domain. I'm looking at the arrow that is going to the right. The arrow is going to the right, it keeps going all the way to positive infinity or just infinity. My range, here comes. So we always go from least to greatest. Alright, every time I'm doing my interval notation, the value on the left is the least, the smallest value. The value on the right is the biggest value. Smallest, biggest, smallest, biggest, all the time. So now we're looking at the range, which is our y-axis. So should I start here at 1? No, that's your highest value, right? So in this case, I need to check below my arrow that is going down. That will be the lowest value. Because I had an arrow going down, then the lowest value is negative infinity. Okay, you always start with the lowest value. On my y-axis, the lowest value is going down, negative infinity, all the way up to 1. And 1 is the highest value on the y-axis. 1, open circle, parenthesis. I just want to make sure that you have that least value on the left side. Because if by any chance you write 1 to negative infinity, this is wrong. Because 1 is not smaller than negative infinity. Right? Keep that in mind. The one on the right, here comes again. Another example of those arrows. I'm going to do my domain. I'm going to do my range. My domain, I go from the left to the right. Why? Because the left is the smallest value. I have an arrow going down, slanted. So that arrow counts as going to the left and it counts as going down. To the left for my domain. Arrow, negative infinity, parenthesis, comma. To the right, the highest values, it will be 3, solid point, bracket. Going down, right? Because now I'm going to go for my range. I look down and up. The lowest value down has an arrow, meaning it's coming from negative infinity. By the way, infinity is like an 8 sideways. I'm sorry, those are infinity, mine is like alphas. So infinity is like something like that. I apologize. Mine is like alpha. Let's go back. I'm sorry. Range. I go down and up. Down, I have an arrow. Comes from negative infinity, which negative infinity or positive infinity always have a parenthesis. Up, the highest value is 2 on the y value, right? On the y-axis. It's 2. Therefore, and it's solid, right? Therefore, bracket. Okay, domain and range. Now, let's go back to our functions and relations, right? I think, domain and range is kind of clear right now. So, for our relations and functions, remember, we're looking to see all of these are relations because we have an x and y function. So, we x and y relationship. How do we know when I have a graph and these graphs are functions? So here comes, and I'm going to use these graphs for that purpose, the vertical line test. The vertical line test. What is this test about? So what I want with the vertical line test is I'm going to draw a vertical line through my graphs. I'm going to draw vertical lines through my graphs. Vertical lines. That's supposed to be a vertical line, I'm sorry. Vertical lines. You see that I'm touching at only one point, the blue line, which is my graph. Then this is a function. Let me do vertical lines. Let me change the color because that red is not really clear. Let me do magenta or a different color, green. Let's go with green, why not? Green, here we go. So let me draw a green line, vertical line, touching my graph at only one point. Only one point. Only one point. Because it's touching only one point, then this graph belongs to a function. What about this one? Blue line is touching only one point. Only one point. That's a function. Right? So let me give an example of something that is not a function. So when we had let me give you a couple examples. So let's pretend this is my x and my y. That I have a circle. Right? Something like a circle. And then let's do another one here. And let's say that I have a parabola but sideways. Okay, this is my x and this is my y. Now, let me bring the green line. Let's do the vertical line test. Vertical line test. How many points am I touching in my circle? 2 points. I'm touching 2 points on my circle. Because I'm touching more than one, right? Look at this. I'm touching more than one. So this is not a function. Not a function because I'm touching more than 1 point. Let's go for this parabola. 1, 2, right here. 1, 2, and remember those arrows keep going. I'm touching more than 1 point, not a function. You can only touch 1 point. Okay, I hope it's clear. All these horizontal lines or diagonal lines are functions because my graph is going to touch only, my vertical line is going to touch only 1 point. Alright, and that's the vertical line test. It's not too bad. Alright, now let's talk about function notation. I'm going to introduce a little bit about function notation and we'll just keep it like that because this is an introduction to functions. Function notation, let's clear this board. Here we go. Function notation. Okay, so we always have equations in y equals mx plus b, right? I hope all of you have seen this before. Y equals 2x plus 3. Right, this is an example. This is my equation. We're familiar with that. We have a y, we have an x. Everything is beautiful. If I need to graph this, I can graph that. Let's say I have y equals, let's say, negative 2x plus 1, for example. All right, we just talk about graphs. Let's graph this using a table of values, which we did already. Table of values, input, output table, right? Input the x, output the y's. I would suggest to use small values when I'm doing table of values. Negative 1, 0, 1, something like that. Table of values, these are the inputs. I'm inputting. This is the values that I decide what to put. Okay, that's why it's called input. What do I do with this? I plug it back into my equation. So I'm going to have y equals negative 2. So negative 2x, in this case is negative 2, right, plus 1. So I replace the value of x. Then I solve. Negative 2 times negative 2 gives me 4 plus 1 is 5. And when I input the value of negative 2 on my equation, I got 5. And this is my output. This is what I got out of it. And that goes for every single one. Y equals negative 2x plus 1. I am replacing the value of x, which in this case is going to be negative 1. Negative 2 times negative 1 plus 1. Y equals negative 2 times negative 1, positive 2 plus 1 is 3. Okay, and I do the same thing for every single value. Negative 2x plus 1, y equals negative 2. What's the next value? 0. Any value times 0 gives me 0. Y equals 1. That goes here. Input, output. Okay? The 1 is going to be negative 2 plus 1 is going to be negative 1. So y negative 2x plus 1 equals, I'm replacing the x by 1. Negative 2 times 1 is negative 2 plus 1 gives me negative 1. Right? Last but not least, y equals negative 2x plus 1. Replace the x by the value of 2. Negative 2 times 2 gives me negative 4. Negative 4 plus 1 gives me negative 3. And that's my output. That's how I create a table of values for any type of function. Alright, just plug it back into the x value. Okay, and that's fine. So this is what we used to. This is what we do every single day in Algebra 1, Algebra 2, many subjects. But the idea is to introduce a function notation. So let me erase a little bit of this and then let me compare those two. So what is the function notation about? By the way, we'll graph this in a minute. Okay, we'll graph this in a minute. Let me introduce the function notation. So instead of having this, I'll have f of x equals. Instead of having y equals negative 2x plus 1, I'll have f of x equals negative 2x plus 1. So f of x, this is read f of x. F of x. That's how we read this. That's called function notation. Okay? So if I have f of x equals negative 2x plus 1. Now we understand that f of x is the same as y. Alright? Okay, that's it. Function notation, nothing else. So every time you see an f of x, it means you have a y. If I want to make this table of values, instead of saying, when the x is this, I said, let's go for this one, negative 2. I'll say, give me f of negative 2. F of negative 2. Instead of f of x, f of negative 2. But look at this. Inside the parentheses, you're supposed to have an x. Now I'm putting in negative 2. So what I'm saying to you is, listen, go to your equation, and wherever you see an x, you're going to plug a negative 2. So you see an x right there? Instead of the x, put a negative 2. That's all what it is for the function notation. Alright, a lot of people get confused, but that's all what I'm saying. And after that, f of negative 2 is equal to, and then you solve. Negative 2 times negative 2 is positive 4, plus 1 is 5. And this f of negative 2 is your y value. This is your y value when the x is negative 2. Again, this is your y value when the x is negative 2. As you notice, I found y, which is 5. So it's just notation. Inside the parentheses is your x value. The whole thing is your y value. Okay? Let's do one more. Let's say the f of 1. Or let me do f of 1. Okay? What's your function? So let me write the function here. F of x equals negative 2x plus 1. I ask you for f of 1. I'm saying replace the x by 1. So negative 2 times 1 plus 1. Negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. So f of 1 equals negative 1. F of 1, x value, equals negative 1. And this is your y value. So f of 1 is your y value. Function notation. Okay, just introducing a little bit of function notation. Later on, we're going to do more videos and explain more in full how do we use the whole function notation. This is just for you to get a little bit familiar. All right, last but not least, we have a table of values. Let's graph that, and I think we're going to end it like that. But let's graph this. So let me get some space here and let's plot these values. All right, so let's graph this function. So what do we have here? X and y. All right, we have anything between negative 2 and 2, and then we have negative 3 and 5. So 1, 2, 1 and 2, negative 1, negative 2, 1, 2, 3, 4, 5, and then we have negative 1, negative 2, negative 3 on the y-axis. All right, here we go. Negative 2 and 5. Negative 2 and x, 5 and y. So I'm going to go up here. You always, let me make sure that we understand that. When I have a table of values, this becomes a point, negative 2, 5. This becomes another point, negative 1, 3. 0, 1 becomes another point. 1, negative 1 becomes another point. And the 2, 3, 2, negative 3 becomes another point. The first value is the x, the second value is y. Whenever we plot it, we always plot the x value first. We go negative 2. So we go negative 1, negative 2. And then from there, I go y, which is 5. 1, 2, 3, 4, 5. And that's where my point is. Negative 1, 3. X values, remember, -1 to the left, and 1, 2, 3, up. 0, 1, 0 in x, I'm not moving. So I stay there, and then I go 1 up for the y. If you notice, I'm getting kind of a straight line. If it's not a straight line, it's because my graph is not really nice. I'm sorry about that. 1, -1. I always, oh, by the way, I didn't say that. I always start here at the origin. And then I'm going to do 1, -1. They go 1 to the right and -1 down, because that's where the y goes. The last 2, -3. I start at the origin. 2 in x to the right, 1, 2. And then -3 in y. -3 in y means goes down. -1, -2, -3. And that's where my point is. You see they're kind of a line? And now the problem is making a straight line. Oh my god, horrible, horrible. Okay, the idea was to have a straight, oh, even worse. I'm not even going to try it right now. So, a straight line through those points. Straight line, straight, oh, better. Straight line. Okay, arrows at the end. I apologize for this line. Alright. And that's it. Guys, don't forget to subscribe to the channel, like the video, hit the notification bells, and we're going to do more videos about functions and more in depth. Okay? I'll see you in the next one. Thank you for watching. Bye-bye.